Well, let's get started with our first example, converting standard form parabola to vertex form. This is our parabola that we're given. Notice A is 1. Well, we're going to use easy parabolas here. B is -6, and the C term is 14. Well, really, we're just going to focus on the B term to get started. We recognize in the perfect square trinomial that the middle term is twice the product of the two terms. Well, let's just undo this. Let's take that B term, the -6, and take half of it. That would be, of course, -3. So I've got now x minus 3, that quantity squared. We'll expand this into a perfect square trinomial, and we have this, x squared minus 6x plus 9. Well, this doesn't quite match this. So, well, let's just adjust it, add an adjustment. How about if we add 5? Well, 9 plus 5 is 14. Therefore, I could just add 5 to this expression. And there you go. I now have written in HK form a parabola. Y equals the quantity x minus 3 squared plus 5. Now, the whole advantage of vertex form is that the h and the k are, well, they're the vertex. In this case, I've got x minus 3, and I've got plus 5 on the end. The vertex of this parabola is 3, 5 in the first quadrant, and we're going to sketch it really quickly. So let's start by plotting the vertex right there, 3, 5. Since I've got divisions of 5, it should be on this line right here. And well, that's the graph I gave you. You could be using your own graph paper, but if you're in my class or you've got this worksheet, this is what you got to work with. So like we learned before, we're just imagining that there is an axis of symmetry here. You don't need to sketch it, but it might be helpful for you. Just sketch a little line there. Use a straight edge if you are going to do it. Please, no freehand. And, well, we know something here, that this parabola is kind of simple. The A term is 1. We know it's positive. It opens upward. So we're going to do a little shortcut here. I want you to imagine whether we count by 1, well, left or right. I don't really care which way we go. If I move over 1 point, 1 unit to the left, for instance, well, 1 squared is 1. So I can imagine that my value, my y value, is going to increase by 1. This is the easy way to graph. I know if I move over 2, 2 squared is 4. So I'm going to have to move up relative to my vertex. I'm going to have to move up 4. Now I could continue this. Of course, now we're going to go off the graph, but that's all right. 0, 14. I look at that, and that checks out with my original standard form as the, right there, the y-intercept. And finally, I could figure out one more point. Again, it's kind of beyond what I've got room to graph here, but I can see these points. I could plot them or estimate them as best as I can, like that. And then with my good smooth graph drawing skills, I could fit my parabola, and it looks like that. So there you go. One done. Let's do another, and we'll call it good. For our second example of converting a parabola from standard form to vertex form, we've got this one right here. Notice the a is still 1. We're going to make it easy. There's only 1x squared. But this time b is 14, and it's a positive 14. Okay, no problem. We're going to take half of that. Half of 14 is 7. Well, okay. And we know how to expand this to a trinomial, perfect square trinomial right there. X squared plus 14x and 7 squared, 49. But we need to make this match this. Well, I guess we're just going to adjust it. Subtract 9. Well, subtracting 9, I guess I could just put that over here. And now this expression, which I'm just going to rewrite here, is the equivalent. So here it is in vertex form. But I'm going to rewrite it. I want to express it a little bit differently. So I want you to see it, think of it this way. You don't have to write it this way, but remember, the form says x minus h in the parentheses, and it's plus k. Well, I like to think of it as x minus -7, because that's your h, and it's plus a -9. That's your k. We're going to graph this one, and the vertex is in the third quadrant, -7, -9. Let's get graphing. We already have the vertex, and we're just going to put it down right there. There it is, third quadrant. And while I'm at it, I'll put in that axis of symmetry right there. And, again, you could substitute if you want, but I find that really tedious. I like to think of relative to this point. I move over 1, up 1. I move over 2, I move up, 4, 2 squared. Remember, the a term, the a coefficient is 1. I move over 3, I move up 9. I move over 4 points. Relative to the vertex, I move up 16. So I could just find all these values really easily just by imagining this. I could just count if I had conventional graph paper, but I could just calculate them like this. There you go. I'm moving up 1, -8. I'm moving up 4 from the -9. I'm moving up 9 from -9, and moving up 16 from -9. Easy enough to plot those points. There you go. -6, -8. I'm moving upward. I can see here, well, -5, -5. Very convenient intersection right there. And -4, 0. You better put this one on the x-axis because that's where it belongs. Now, -3, 7. Let's put this one in there. And before we go to draw our curve, remember, this is an axis of symmetry. So I'm imagining, I'm taking these points, and I'm just like that, I'm drawing them on the other side, directly opposite of this axis. So now I could just draw my curve. And it's going to look, well, if you have a really good hand, it's going to look like that. Keep in mind, this is really this graph, y equals x squared. Y equals x squared, that's your coefficient of 1, and all we did was shifted it down here. That's the whole beauty of using the vertex form. Well done.